A very warm welcome to all my friends in the first episode of integration by using trigonometric identities. In the previous section, in the previous video lessons of integration, we learned about the substitution method. That was our first method, substitution method of integration, that can be used for both finite as well as indefinite, definite as well as indefinite, both type of integration questions. And here before starting using trigonometric identities, let me tell you one thing. My dear friend, as we used to solve the integration questions by substitution method, we generally used to follow 6 steps, 5 to 6 steps we used to follow. Same here also, we're going to just use again few steps. That's everywhere we're going to apply. All substitution methods questions we solve almost in a similar way. So again, integration question can also be solved in a very similar way. Always try to understand whenever you're going to solve problems. Let me first tell you, if we have our integrand something like this, let's say x to the power n dx, then we used very simply, we write there that it's x to the power n plus 1 divided by n plus 1 plus some constant, right? Let me give you an example, like let's say x square dx it is. Then we simply did x to the power 2 plus 1 divided by 2 plus 1 plus constant, and that was x to the power 3 divided by 3 plus constant. That's where that is our solution. But my dear friend, if I have, let's say, integration, let's say my integral is cos square x dx. Now can I do like this? Again, the same, power is 2, so it will be cos 2 plus 1 x, cos x 2 plus 1 power, and again 2 plus 1 plus constant. Can I solve like this? Absolutely not. You can't solve like this. All right, we cannot integrate like this. Okay, so for this type of the things, as we cannot do in this way using the power rule of integration, so we have to use trigonometric identities. And now how to use the trigonometric identities, that comes first. All right, we have learned 6 formula of trigonometry, in which we have the direct formula, a very standard direct formula of integration, and the first one was like integration of sine theta with respect to theta, or you say x, that same thing, and that was minus cos theta plus constant. And another one was cos theta d theta, that was sine theta plus constant. And then we had a lot. And again, integration of sec square theta d theta, that's tan theta plus constant. Similarly, 3 more formula we had learned. Integration of sec theta tan theta d theta, this is sec theta plus constant. And then integration of cosec theta cot theta d theta is minus cosec theta plus constant. And the last one was cosec square theta d theta equals to minus cot theta plus constant. So these are the 6 standard formula of integration we learned in the first almost initial stage of the integration, when we introduced integration. And whenever you get any problem like this, let's say here integration of cos square x. Now cos square power is 2. If it was sine square, or let's say simply tan square or tan or something, like that, then that time we have to use this type of these 6 formula. Any of them, it will be not all at one time, any of them can be used, or maybe 2 or 3, any can be used, but I mean to say this formula we need to use. And now the matter comes, how do we use them? All right, to use this trigonometric formula, we have to again use some identities that we learned in trigonometry, like for example, the same problem I'm going to do, cos square 2x. all right, so let's say my integration is cos square 2x or x, let's say x it is dx. Okay, so how do I solve it? I learned that integration of cos theta is sine theta, but I haven't learned cos square x dx. I don't have the direct formula for this. It means if I'm not having, if my expression, if my integral, or if my integration question is not falling under this 6, it means keep in mind, it means we have to work out there, we have to use some identities, and we need to convert them all into these 6 standard. Any of them will be applicable at the beginning or at the last, but we have to use any out of these 6. We must have to use. All right, and how? Now how do I convert that into this 6 format, of any of the 6 format? I must have to convert this cos square x into any of this one, but how? Now that thing comes completely, you know, it will take you all concept of the trigonometry. So now you need to search any trigonometry formula in which cos square theta comes. Definitely there should be cos square x or theta, does not matter, plus along with that, maybe plus minus, along with that any of this, you know, any of this should be there. Either cosec square theta should be there, or sec square theta, or cos theta, or sin theta, sec theta, tan theta, or cosec theta, cot theta. Anything should be there. Angle does not matter, maybe 2 theta, 3 theta, angle does not matter, but the power, you know, it should be cosec something angle, cot something angle, like that, you know, cosec square, you know, something. So it should be any of them. So now I'm searching in my brain that what is the formula in which I will get cos square also, and I will get a formula from these also, you know, I can use this formula also, so that I can convert this into the formula format. And now one thing is coming in my brain, that I had learned cosine of 2 theta is 2 cos square theta minus 1. So from here what I can say, that cosine of 2 theta, this minus will come this side, it will be plus, will be equals to 2 cos square theta, and cosine of 2 theta plus 1 divided by 2 is going to be cos square theta. And don't you suppose, my dear friend, this cos square x is exactly in this format. So if I'm writing here cos square x, then this will be cos 2x plus 1 divided by 2. And further, if I'll write it in a proper way, so it's going to be 1 by 2 cos 2x plus 1 by 2. And integration of, if I'm now doing integration of this, you know, now, you know, cos square has been converted into this. Integration of this is not possible, but integration of this is very simply possible, very easy, because 1 by 2 and cos, this 1 by 2 I can write outside, you know, and then it will be integration of cos certain angle, and I have the direct formula for that, integration of certain cos angle, you know. That was the trick. Did you get it? So like this, you need to use any trigonometric identities. Like here I used one identity, you may have to use any identities. Alright, so be perfect in trigonometry before starting integration using this trigonometric identities. So any of them can be used anytime. Alright, so let me do it a little properly. This the same question, this question I stand for integral of cos square x dx. So this is what? Cos square is actually cos 2x plus 1 by 2. Alright, so what I'm doing, I'm writing here cos 2x plus 1 and half, here is also half, alright, dx, and in the next step I'm going to separate the terms, so it will be 1 by 2 integration of cosine of 2x dx plus again integration of, if there is nothing, there is 1 dx. Okay, now it's 1 by 2 and integration of cosine of 2x. Now you have to look at the formula. Integration of cosine of theta is sine theta plus constant. Alright, so it's sine theta. Theta is here, 2x plus some constant. Constant always comes. But my dear friend, it's okay. But when it is, you know, look at the formula again. I'm telling you, look at the formula again. When it is theta, there was theta. Okay, but in my question here, it is 2x and here is only 1x. It means I have to always multiply by the coefficient of that. It means I have to divide by the coefficient of that. I need to divide by this 2 here. Alright, 2. Okay, keep in mind that. And here I will tell you this later. And integration of this is half integration of 1, that is simply x plus constant 2, you know. And my answer is 1 by 4 sine 2x plus now constant by 2. Let's say this is constant 1. Alright, so constant 1 by 2 and again x by 2 plus constant 2. So in the place of this constant 2 and constant 1 by 2, I can together write 1 by 4 sine 2x plus x by 2 plus big constant, and that's my integral. This is how I need to solve. We have to solve using the trigonometric identities. And now let me tell you how this came. If you use this, if you use this here, you know, if you find the integration of this by substitution method, it will be very clear. If your integral is, let's say, cosine of 2x dx, then let's say t equals to 2x. So dt over dx will be 2. Okay, so dt over 2 is going to be dx, and now my integral is converted as a cosine of this 2x. 2x is t and dx is dt by 2, so it's dt and 2 is coming outside, let's say, so it's 1 by 2, and integration of cos t is sin t plus some constant, so it's simply sin t by 2. All right, plus constant. And what's my sin t? What's my t? T I have supposed as 2x. All right, 2x divided by 2. So this is what I was trying to make you clear. When the x has coefficient, whatever the coefficient we have, that coefficient always after integration divides that whole expression. All right, so here sin 2x divided by 2, that's why I have written here sin 2x, integration of cos 2x is sin 2x and divided by 2. If it was only x, then again this will be x, but the coefficient of that is 1, which will be here, but dividing by 1, no need to write. That's why we don't write generally. And if it was like, let's say if it was like 3x, then it will be 3x and 3 will be here. Let's say if it was 5x, then it will be 5x and here will be also 5. All right, so keep those stuff in your brain properly. This is gonna help you a lot. All right, so I will see you guys in the next video, and if there is any confusion, any doubt in this section, then please feel free to comment below this video, and I will be really happy to see you in the comment section. And please subscribe the channel and hit the like button. Bye bye.